Hello everyone and welcome to the channel. I'm Emmanuel, I'm an Airbus pilot, and welcome to the Airbus A220 Autopilot tutorial. In this video we are first going to talk about all the modes that are available and what they're going to do, and then we're going to do a little demonstration of a standard autopilot sequence for a normal flight. Alright, so let's go ahead and get right into this one. The main interface between the pilot and the airplane is the Flight Control Panel, or the FCP, which is that panel up here. This panel includes all the inputs that we as pilots can make to the autopilot system. On the contrary, the main interface between the airplane and the pilot, so when the plane wants to talk to the pilot, is the flight mode annunciator at the top of the primary flight display over here. This, and only this, is where the airplane tells you what it is actually doing. It is a common mistake amongst flight simmers to look at green lights and stuff on the flight control panel. Don't do that. Look down here. Only here is where the airplane tells you what it is actually currently doing. So, let's talk about the different, let's talk about the setup of the flight control panel. The flight control panel is divided into 4 different parts. Namely, you got the speed or the thrust part on the left side, then you have your lateral modes, then you have the kinda managed vertical modes. Yes, level change counts for that on the 220, and then you have the selected vertical modes on the side over here. And obviously you do have the autopilot engagement buttons in here and the emergency descent mode, which we're going to talk about at the very end. So let's go ahead and get started. And we're going to start with the speed and the thrust. Over here you can actually not do too many inputs, but you can select between FMS speed control and manual speed control, and when you're in manual control you can simply select whatever you want. Note that the manual value can be adjusted automatically by the airplane when you are flying in a condition where the lower amber band on the speed, which is the minimum selectable speed, rises. So for example, when you're climbing to high altitude or when you're pulling high Gs, and that can adjust the manual speed that you have pre-selected. Normally, prior to the flight, we do select the V2 speed in here, so that's 131 for today's flight. The reason we do this is because we take off with FMS speed control so that the airplane automatically obeys all the FMS targets, but if we have an engine failure and we need to return to V2, simply select manual and there you got it. You also have the Erst Mach button in the middle of the switch that you can simply push in over here, and as you can see, that switches the display around between indicated airspeed and a Mach number, which happens automatically when passing 27,500 feet, but you can switch that manually here as well. Also located on the left side is the flight director switch, which can be used to turn the flight directors off. Note that in order to turn the flight director on, you would normally simply engage a mode. So for example, if we want heading mode, you simply press the button, you can see the heading mode comes on, but if you want to turn the flight director off, that's the switch where you do this. Now, that's the speed panel. Let's go ahead and continue. So the next panel is the lateral modes, and that's the panel located right over here. So, couple of things. You got your heading at the top, and note that in the A220 you only have the heading. You cannot transfer it to track or something, you only have heading as your option. Then you've got 3 different modes available over here. Heading is kind of obvious. You will fly a heading. Then you've got nav. Nav mode is going to track whatever current nav source is selected. So right now we have FMS selected as our nav mode, but this can either transfer automatically or manually using the nav source switch over here. And if you switch this, for example, to localizer and then press nav, then the airplane is going to engage in localizer mode. The same also applies to VORs, and note that if you're flying right over a station, you can get a dead reckoning mode as well, which would come on automatically for when you're overflying a VOR. So, with the correct nav source selected, pressing nav is simply going to engage that mode. Now, the airplane is by default going to use FMS mode. So, FMS is what you're going to be in, usually, and then pressing nav is simply going to engage FMS1 or FMS2, which you would get on the FMAs. So if we just press this, you can see on the ground it simply arms the mode. When you're in the air, it would capture under certain conditions, and then in FMS mode it's going to follow the route from FMS1. In FMS2, the route from FMS2. Now that is kind of obvious. Next up is approach mode, and approach mode has a couple of different modes that it can arm on the lateral side. Namely, it can either arm approach FMS, which is going to guide the airplane with slightly increased accuracy compared to the normal FMS mode, and then you either have VOR or localizer modes, quite similar to nav mode, which can be used for your lateral tracking of an approach. Note that the approach mode also has an effect on the vertical FMA, on the vertical function, but I'm going to talk about that later when we get to the managed vertical modes. So, next up is your heading bug. You can just set your heading bug as normal over here, and when you press push to synchronize on the ground, then it's going to synchronize the heading to your current heading, which is fairly useful when you have lined up on the runway and you simply want to synchronize the heading bug. But when you're in the air, the functionality of that button changes, and pushing that mode is going to blank the heading display out, and the heading bug is basically going to get stuck to your current heading. That's a fairly useful mode, so I'm sure Boeing pilots will remember. You don't have to constantly move the heading bug around to follow the actual track. You simply press this, then the heading display goes blank, the heading bug follows your current heading, and if for whatever reason you need to switch to heading in flight, press the heading key, and then you're right away in the present heading. Finally is the half bank button along our lateral guidance. And half bank basically halves the bank angle that the airplane is going to use in heading mode only. So nav mode always calculates the maximum bank angle live. So if you're in FMS1, the airplane is only going to bank as far as it needs. However, with the half bank button active, and note that this function becomes active automatically above 31,500 feet, the airplane is going to apply half of the maximum bank angle. So maximum 30 degrees, half that 15 degrees. That's because the increased G-loading when maintaining level flight at high levels could cause the minimum speed to come up quite significantly. Now again, nav mode, respectively FMS mode, automatically calculates the maximum bank angle it can do under the given circumstances. For heading mode, the half bank function takes over. Now, let's move into the next panel, and that's the autopilot and auto throttle engagement right over here. AP turns on the autopilot. Logic. AT turns on or arms the auto throttle when you're on the ground, respectively turns it on in the air. The transfer switch is used to transfer which side controls the different modes, mostly the heading or the nav and the approach modes. So let's see how that one works. You got that arrow on your FMA over there, which tells you which side is the active side feeding data to the autoflight system. If the arrow points to the left, it's the left pilot. If it points to the right, it's the right pilot. Now, when the first officer or the pilot on the right-hand seat becomes pilot flying, press the transfer mode, then that thing transfers over, and now his data becomes the master data. This is quite important because you can have different nav sources selected on both sides. So for example, I could select Localizer 2 on the right hand side while FMS is active on the left hand side. Now, if you press the nav mode and suddenly the plane engages in a mode that you did not expect, for example, if you're flying from the left hand seat and you press nav mode and it goes into lock 2, but you have FMS 1 as your nav source, then check which side is selected up here, since right now it's taking the data from the right hand side system, like this, where a different mode may be selected. So quite the important thing there. So make sure that you got the correct side selected from where you are flying on, like this, and here we go. Now lastly, we do have the EDM button down here. This stands for Emergency Descent Mode. Now Emergency Descent Mode activates automatically when you're above 25,000 feet if the cabin altitude exceeds 14,500 feet. You can also select it manually only when you're above 25,000, and the following is going to happen when this mode activates. The cabin is going to get and the flight deck are going to get an emergency descent oral alert. Autopilot and auto throttle engage automatically, even if they've not been engaged previously, and the thrust is reduced to idle. The altitude is pre-selected to 15,000 feet, but the pilot is able to adjust this manually, and heading mode is going to engage and present heading is maintained. Again, you can adjust this as pilot. The descent speed is set to VMO minus 10 knots or MMO minus 0.02 Mach, and the transponder is automatically selected to 7700, and the seatbelts come on if an automatic EDM activation took place. If you activate the mode manually, the latter is not going to happen. One important thing, the speed brakes are not going to extend automatically. So basically, here's what the mode is good for. When you're above 25,000 feet and you encounter a decompression and the cabin altitude rises above 14,500 feet, the airplane is automatically going to initiate an emergency descent down to an altitude of 15,000 feet. Note that by standard EASA procedures, you would have to descend to below 10,000, obviously providing that the NSA allows it, and you would have to turn 45 degrees off track. So basically, when the mode comes on, all you got to do as pilot is to watch the automatics, take the airplane down. You just got to adjust your altitude and track and extend the speed brakes manually. And that's the emergency descent mode. Really, really useful thing. Now let's move on to the managed vertical modes. Over here we are going to start with FLC mode. FLC engages the auto throttle in thrust mode, which is either going to provide idle in a descent or maximum climb thrust, or respectively the climb thrust selected down in the FMS, which can be climb, climb 1 or climb 2. The auto thrust is going to engage in that mode, and then the airplane is going to follow the target speed from the speed over here and pitch to maintain that speed. So that's the default climb or descent mode that's going to be used. Then you have Alt. Alt, when you press the button, is going to maintain the altitude that the airplane has at the time the button is pressed. Respectively, it would come on automatically when you reach the selected altitude in level change or vertical speed or flight path angle modes. Now there's VNAV. VNAV on the A220 works quite different from your typical Airbus or Boeing. So VNAV isn't a mode on its own except for descent. Much rather, VNAV is usually armed on top of either vertical speed, flight path angle, or flight level change. The default is flight level change plus VNAV, like this. Now, what the airplane is going to do is VNAV is going to add a little V to the FMA. You can see that down here. Default would be just FLC. If VNAV is engaged, a V is going to be added. Now, what's that going to do? So, VNAV will level off at any programmed FMS constraints, which are, by the way, also going to be shown on the primary flight display next to the manually selected altitude. So, for example, we have a sub-zero above restriction in our FMS right now. Like here, if this wasn't sub-zero above, but for example, sub-zero below, let's just enter that one as an example at Mike Sierra Echo over here. So crossing, we want at or below, and I want an altitude of 5,000. Like this. Execute. You can see that the airplane in VNAV would now level off at those 5,000 rather than the manually selected 8,000. Now, if you are in a descent and a VNAV profile exists and VNAV is armed, then the airplane is going to transition into VNAV path mode for the descent. Now, VNAV path is just a vertical mode. It is not a speed mode in the airplane. So the airplane is simply going to follow the profile, and it doesn't care if you exceed a speed restriction. It'll give you a message telling you that it's about to do it, but it will simply do it. Now, finally, let's have a look into the selected vertical modes. Vertical speed is quite simple. You select VS mode, and then you can dial in a vertical speed. Easy as that. Flight path angle on the other end side is going to define a flight path angle for the plane to fly. For example, if you tell it to fly -3 degrees, then the airplane is going to follow a standard 3-degree path. Pretty useful stuff. Finally, also a brightness selector that you can use to control the brightness of the FCP. Lastly, something that I forgot earlier is the altitude select knob. So this one can choose between either feet or meters. And if you go to meters, very useful for flying in China, you can simply dial in the altitude you need. And feet, it converts them 1-to-1, and that's feet. By default, this thing works in thousands, and you control that using that part of the knob over here. If you need to set altitudes of 100, push the button in the middle, the push fine button like that, and now you can select the altitude in steps of 100s. So, again, very useful thing. Now let's have a look at what the airplane could tell us. We've just talked about what we can tell the airplane. Now let's have a look into a normal flight sequence and what the airplane is going to tell us and what all the different modes are going to mean. So, we're going to start quite easy with the initial modes that we need. And the first mode you're going to need is going to be the toga mode. So toga, takeoff go around, is the standard mode used for takeoff, and it can be engaged by pressing either the toga switches down here on the thrust levers, or there is a hidden click spot up here that you can use to engage the mode. So when we press that toga switch, you can see three things happening. First, you got the lateral flight mode annunciator here, which tells us toga is now active, so the airplane is simply going to follow the runway track. Then you got the vertical toga mode, which is going to pitch the airplane in order to maintain the target speed commanded here. You will also note that Alt-S is going to arm, which means altitude selected, so the airplane is going to level off at those selected 5,000 feet. You will also see that the flight director comes on with those brackets over here. What this means is that you are supposed to pitch the airplane, so put the vertical path of the airplane symbol here into that bracket, and the bracket is going to change to command the exact pitch that you're supposed to fly. Now, if you are going to depart in heading, then you can simply leave it like that. Some airlines would ask their pilots to arm heading mode for the takeoff. However, that is not what most airlines do. So if you are departing in heading or on a vector, then this is what you're going to do. If you are departing on a standard SID, then after making sure that FMS is the active nav mode, you are going to arm the nav mode, and you're also going to arm VNAV mode. Now this is what it looks. You can see whenever the FMA changes, the thing is going to flicker. Now FMS 1 is shown in white, meaning that this is the armed mode, and we can see that our takeoff FMA has been expanded by a V, showing us that now VNAV is going to have an effect on the active modes. You can see that on top of VALTs, we also get VFLC armed now, which means flight level change added with the VNAV function. Now this is our standard setup for the takeoff. Now let's make sure we are in FMS speed, let's make sure we got the heading and the initial altitudes, and that is all done. So with that, our airplane is now ready to go in terms of the autopilot management. So, once you're aligned on the runway, we are going to press the auto throttle key in order to arm auto thrust. And you can see that this also arms thrust mode and auto throttle on our FMAs as well. Again, this is how the airplane tells us that the modes are armed. Disregard any of the green things over here. This is how the airplane communicates with us. Alright, so this is a standard setting for our takeoff, so let's go ahead and release the parking brake and take off, and then I'm going to take you over what the airplane is telling us and which modes you're expecting at what time. Alright, so standard takeoff technique with the autoflight system is that with those modes shown to you over here, you are going to advance the thrust levers to 55% and 1. We can see the engines run up simultaneously, very good, and then we simply push the thrust levers all the way forward. This engages thrust mode, and you can see speed mode has now armed. So thrust mode is going to set the thrust automatically while the airplane accelerates, initially to about 60% of the maximum. Note that that does not equal 60% N1, and by 80 knots you will get the actual commanded takeoff thrust. Then the FMA is going to transition into hold. So reaching VR, we are going to rotate the airplane into the brackets, and then we are going to follow the brackets on our way up, like this. So positive climb, gear up. Now at 50 feet, FMS1 comes on, and thrust mode re-engages, and through 400 AGL we can engage the autopilot, which is going to be shown to us by AP coming on over there. Now we got the flight director in magenta, and we got the green bird telling us what the airplane actually does. At the FMS programmed acceleration altitude, VFLC is going to come on, and now the airplane is going to maintain the thrust commanded from the FMS, and it's going to pitch to reach the target speed. And this is quite simply how the autoflight system does that. Passing the F1 speed, we're going to retract the flaps to 1. And you will see that once the flaps are actually retracted into 1, and when our limiting speed increases, the target speed is also going to be increased by the VNAV system, and then we can retract the flaps to 0 when passing the F0 marker, and that's it. You can see that the airplane does follow the speed constraint from Mike Sierra Echo over here, which has that 220 constraint, and VNAV automatically follows that. Now we're approaching the target altitude, and you can see that altitude capture comes on, together with the speed mode. And like that, the airplane is now going to capture the target altitude. Now, that's pretty much how the airplane is communicating with us on a standard flight. Let's go ahead and have a look at what we can do now. I told you earlier that pressing the push to sync button on the heading panel is simply going to synchronize the heading bug. Let me just detune that. In Boeing aircraft you would constantly have to retune this. In the A220 you simply press this, and now the heading bug is automatically going to synchronize with your route of flight. Very, very easy. Now, let's go ahead and have a look into what a normal flight sequence would look like. You would basically stay in VNAV for pretty much the entire flight. We've reached cruising altitude, and we are now approaching our VNAV descent. So what you would do is dial in a lower altitude with VNAV armed. It's going to arm VNAV path mode, and then it's eventually going to descend. All easy stuff. So let's go ahead and give ourselves a vector over here and fly ourselves onto downwind for the approach. Now over here, there isn't all that much that we actually need to do. So what I'm going to do is to turn on a little bit of time acceleration to get us into correct position over here. So let's go settings, time compression max 4x. And we are now just going to fly that traffic pattern and get ourselves into a position to fly an approach into Munich. Now, this is not an FMS tutorial, so I'm just going to go over that real quick. And I will simply let's say, delete all that SID. So Nelby, copy. What is it doing? AA? No, we don't want that. Alright, so copy Nelby, put it up here. Thank you. That's it. Okay, and now we're going to fly ourselves towards the approach. Now, what you can see when you're in your flight is a couple of things. So, first of all, the autopilot does have some protection modes. In other words, when you are flying into an overspeed or an underspeed, let me demonstrate that here. I'm going to turn the auto throttle off and just set maximum thrust. When you are getting too fast and approaching an overspeed condition, the airplane does have protections available. So, by either going into OSPD or USPD, you have an overspeed and an underspeed protection available to you. Let's go ahead and have a look into what that would look like. it warns us. Now it goes into the actual overspeed. You can see we get the warning. And of course this worked on the last flight, not on this one. Let's select this up. Here we go. Now when we're in a climb or a descent, you can see the overspeed protection come active from the autopilot there. And that's it. You have to be a little careful because the airplane is not going to protect you when you're in level flight. And as you can see, the auto throttle does not automatically engage. Note that if the autopilot is not engaged either, you're not going to be warned about that. And it is not going to re-engage. So there is no automatic engagement of the autopilot or auto throttle when the overspeed or underspeed protections come active. Alright, so let's go ahead and prepare our airplane for our approach. We're in 6,000, we can descend down to 5,000. There's 3 ways we can do this. Level change is the default mode, but if you're only doing a small altitude change, I would recommend the use of vertical speed. So let's do 1,000 feet a minute. Let's also re-engage auto throttle. And here we are, descending back down to our profile. So let's go ahead and turn base. So left turn heading 350. And now let's talk about the approach. So the autopilot of the A220 on the approach is a little bit annoying, to put it that way. Namely, what the airplane does or doesn't do is it does not have a very good capture mode. So you are going to pretty surely overshoot when you're capturing a localizer. Now, that's obviously not desired, so what A220 pilots would do in the real world is either fly yourself onto the localizer manually or fly RNAV approaches. In fact, RNAV approaches are the most commonly flown approaches on the Airbus A220 for that very reason. And I'm going to show you why in a few moments. So we're now approaching the center line. Let's go ahead and turn onto an intercept heading of 290. I'll let the airplane turn onto that track. And now you can see the following. FMS1 is still the active nav mode and will remain the active nav mode. In blue, you can see that the airplane has armed the approach. So the blue data you see is the localizer that's been automatically tuned. Now, pressing approach mode, you can see that localizer arms, and when you get close enough, localizer is going to become the active mode. So you have that unfortunate tendency to overshoot, as you can see right now. The airplane is going to correct for it. It is eventually going to intercept the localizer properly, but the problem exists. And that's not a bug, that is actually a feature. And that is the reason why most A220 pilots are going to prefer manual control over using, or RNAV approaches, over using the automatic features there. Now, finally, let's just go ahead and set up our V-speeds for the descent over here. For the deceleration segments, normally manual speed is going to be used, as you can see over here. And when reaching the desired f-speeds, we can reduce our speed further and fly the plane like that. Now, note that you can still see the managed target over here. Alright, so we're intercepting the glide slope now. You can see it's still really sloppy following that. And that is in fact how the real A220 behaves. So don't be surprised to see this. There's the runway. Here are we. This is an A220 thing, guys. It really is. Even though, I'm honest, I found it very hard to believe that. But so many different A220 pilots have told me about this now that I do actually believe it now. Okay. So, we're established on the final. We are following the speed guidance. We are basically doing everything manually over here, which is pretty much how this airplane is flown. Now, when you're not on heading mode, just push to synchronize, and that's how you fly this. Alright, so the minimum use height of the autopilot on the approach is 80 feet. So if a manual landing is planned by 80 feet, you need to disconnect the autopilot. Now,
2500.
Let's have a look at what we've got on our PFD right now. So, approach and localizer 1 are currently engaged. Glide slope is engaged, telling us that the plane follows the glide slope. We have our missed approach selected over here, so 5,000 feet. And finally, we can see that FMS 1 shows in blue because the airplane is arming the missed approach mode, which would be in FMS once again. We can see that now the one from the localizer has disappeared because now the airplane is going into a higher accuracy of tracking, and you can also see that because I turn a little bit to the left, now it's actually intercepting everything properly in a preparation for an automatic landing. Alright, so let's go ahead and start configuring ourselves for that landing. Now you can see approach 1 is engaged over here, telling us that the current mode is category 1 guidance. Now you will see that later this will change to approach 2 or 3 for Cat 2 or Cat 3 guidance. Okay, so we're slowing down. Target speed 128 plus 5, so 133. Let's set that. And note that VNAV is not certified to set your speeds on the final approach. You need to do that manually. It's weird, but it's how it works. Alright, so we've now intercepted the final. We are now descending, and you can see that land 2 has come on. Let's quickly talk about the auto land. At 150 feet, you would get a line on the lateral mode, so that the airplane aligns itself with the runway centerline. At 65 feet, you get flare vertical mode. At 20 feet, you get throttle retard. And once you're on the ground, plus 2 seconds, you get rollout mode. If at any point in time you need to go around, simply press the toga button, and the airplane is going to go into a go around. And you will notice that nav mode and lead needs to be checked. In many cases, it's going to arm automatically, but that depends a little bit on the airplane itself. Alright, so align mode is active, flare mode is armed, and retard mode is armed. And like this, you could completely let the airplane come down for an automatic landing now. Again, 80 feet is the minimum view height for the autopilot on the landing, so at any time down to 80 feet you can disconnect and land manually, like this. Now you get the no auto land warning, obviously.
50, 30, 10.
And that way you can either land it manually or automatically. Easy going. There is no automatic reverse, you need to do that manually, and that's pretty much everything there is to this. So, that's pretty much everything you need to know about the autopilot on the Airbus A220. Thank you very much for watching. I hope you found this one interesting. Leave your feedback in the comments underneath, as well as your questions. Finally, I can also very much recommend the A220 pilot guide from A220 driver. Yeah, very similar username to my own, but that's not me. That is linked in the Synaptic Discord, and that is available through the Synaptic website. Very, very useful thing, which contains a lot of the information that I included in this video, and a lot more. Very helpful stuff to learn the airplane. But for now, guys, thank you very much for watching. As always, like, comment, and subscribe. And if you really like this type of content, leave your feedback in the comments underneath the video and consider a small donation through the Buy Me a Coffee link in the video description below. Thank you very much, and with that, I'm really looking forward to see you all again on the next one.